Good morning, IB. It's been a little while. Last time I saw you was in Argentina, in Buenos Aires, at least for some of you. It's an absolute pleasure to be here. I'm very, very grateful to Oli-Pekka and his team for having invited me. And this is going to be really a session that's going to hopefully set new goals in everyone's minds. We've all been confronted to AI, and we have to understand its impact. In recent times, of course, everyone has started worrying about how do I do this in my classroom, what kind of policies do I need, but that's a transitory phase. The real impact is going to be on the future of occupations and life itself. And that's what we need to discuss. How can IB prepare all these students for a very, very different future? So there's a lot to cover. We're going to talk, of course, about AI, what's hype versus what's reality. We're going to talk about the impact on occupations. We're going to talk about what are the consequences for jobs and, therefore, education. We're going to talk about knowledge, skills, character, etc. And also the impact on the how. So not just the impact on the what, but the impact on the how as well. This is going to last 45 minutes. We're going to have a 15 minutes Q&A at the end. And before I forget, at 5:15, Oli-Pekka and I will also have another session in the Archives M4 room, Archives M4. We still have only 40 seats left. We only have 40 seats left for whomever wants to come for more Q&A on these topics. By the way, we'll be giving copies of the book away. All right. Fasten your seatbelt? Yeah? Okay. So very quickly, I have to introduce what my center is. We try to develop vision ahead of the pack. And, honestly, it's been 10 years that we've been looking at this. So it's not new for us. I know that a lot of people have suddenly discovered AI since November 2023 and have become experts overnight. But for some of us, it's been a long journey. And we've been partnered with a number of prestigious organizations. You see here the IB, you see the OECD and others. You see also top-end jurisdictions like Finland, which is where I met Oli-Pekka in the first place a decade ago. And so this is what we're aiming to do. We're aiming to work with the best to make the best even better, to respond to the needs of the future. So very quickly, I'm not going to go through all of this, but the thing to notice is what you see circled in red at the bottom. I've been in AI for 30 years, and I've seen its ups and downs, and one of the things I intend to bring to you is a sober yet profound view of how it's going to change education, but change the world. But it's sober, it's unhype-ish. So during my career, I've seen this 100 million-fold improvement in processing power. That's because of exponentials of semiconductor capabilities, microchips, right? At Moore's law, capabilities doubling every 18 months, 100 million-fold improvement. And all of a sudden, the things that the 1960s dreamt about are happening. 50 years later, that is what it takes. At the time when I started Neurodyne, we could only compute 3 layers of neurons. Now we can compute 5,000 plus layers, and that makes an enormous difference. Enormous difference, and you've seen it around you. Oh, wrong button. So let's talk about hype versus reality, okay? Any progress, any technological progress, but also evolutionary progress, even for species, is a series of punctuated equilibria. This is per Stephen Jay Gould. And we see this in technology all the time. Progress doesn't just continue on unabated, linearly, simply like that. It goes through steps, stabilizes, goes through another step. In the 80s, we had symbolic AI. In the 90s, we had expert systems. In the 2010s, we've had narrow machine learning, and now we have broad AI, broad in terms of its language capabilities. And we're going to continue seeing this progression, but it doesn't mean that the progression doesn't slow down at times, kicks up again, etc. I'm trying to make here the distinction between what this phase is about, which is what we call capable AI, versus what people will call generalized AI, meaning an AI as smart as a human, or an AI that's super intelligent, meaning as smart as all humans. Now, of course, you can drive a truck through these definitions, but that's not the point. The point is we are right now at a phase that is at the same time overhyped, yet extremely potent. This is how it all started in the 2010s. We were able to start solving so-called bounded problems, even if the computational space was enormous, like the game of Go or chess or whatever, or Stratego. And with this sort of capability, where you train an AI on a finite set of rules to do a finite job, it does incredibly well. And that's why it figured out how proteins fold by the millions, whereas it was so painstaking for humans to do with the equipment they had. And now it's being used to sort through chemicals to figure out what would be a good drug, etc. But these are, again, bounded problems. I'll get back to that. This is really an important distinction. Nevertheless, these AIs rely on neural networks. And these neural networks, which are imitations of a very, very, very crude imitation of the human brain, extremely crude. Did I say crude? Crude imitations of the human brain. They're greedy. They require a ton of data to be functional. To give you an analogy, when I was 5 years old and I put my fingers in the power socket, it took only one iteration to learn not to do it again. I didn't need, 6,800 years of trying, although it may explain a few things in how I function. Robots and like. And they're brittle. For an AI, that's a face, either way, because it recognizes the features of a face. But of course, we know that a face has to be recomposed. And it doesn't take much to fool it. That's why it's brittle. You add a few stickers on a stop sign, and it thinks it's a speed limit. And these features are still correct even with the modern world of language models. Then they're shallow. They used to be quite shallow, actually. If you train them on recognizing dogs, everything is a dog. And here's another example where everything is a dog. And if you don't believe me, here's another example. Everything is a dog. And one of the features is that you can overtrain it to find dogs, right? So you can overtrain it, it's going to find dogs everywhere, like here in the supermarket. Now, of course, who doesn't love dogs, right? So that's a good thing. That's a good feature. So it's brittle, and it can hallucinate, but mind you, like human brains do. Hey, just saying. Then it's brittle. You have to format the data. At least you had to format the data much more carefully than the ragu sort of data set. And then it's opaque. You don't know how it converges, which is fine in some occupations, but if you're going to be asking a healthcare AI a medical question, you would want it to A, not hallucinate, and I think, and B, not be opaque. Like, tell me again, why do you think I have cancer? Oh, I just decided that you do. Thanks. Very comforting, very comforting. So they're opaque. We don't know exactly how they converge, and that's, of course, not acceptable for assessments, I don't know, of a paper or whatever. We need to know why. But what has changed that's really, really profound is by training those AIs on much broader sets of data, we have broken the bounded problem barrier. Now, this is unbounded, bounded only by the giant set of data. It's giant. It's not everything in the world, but it's giant. That means that they cannot be just experts at some narrow thing. They can also transfer. And this ability to transfer has amazed us because you train them on one type of question in a language model, and they're able to figure out things in other language models, language domains, even languages. They can figure out grammar of languages by training them on one language and then comparing to other languages. So they do transfer. And if you think about what's an education for, it is about expertise and transfer. We're here as educators to make sure that a student can function 20, 30, 40, 50 years hence with what they've been taught. They have to transfer, right? They learn something in 5th grade, and 50 years later something happens, and they know how to adapt to that new situation. They transfer. So now we have machines that can do forms of transfer. But everything is pushed by hype. And this phase of technology is no different than other phases of technologies or other technologies to begin with. Remember, these people, OpenAI and others, have to raise billions and billions of dollars. If you went to an investor and said, you know what, it's going to be like the railroads. Most of you are going to lose their money. Just give us a lot of money. And eventually, someone will make money. Nah, not very comforting. So hype is built in, not to mention the ego, of course, of the people who are running these places, because they all want to up one another. So, oh, you're only working on language models? Well, I'm working on AGI, says Meta. And, oh, you're just working on AGI? Oh, I'm working on superintelligence, says Ilya. Come on, guys. Nevertheless, reasonable actors like the Gartner Group show that this hype about generative AI is starting to go down, which is normal in technology, because then the real work starts, and we're going to show you how the real work actually is incredibly potent. Think of it as the transition from a scientific phase to an engineering phase, where all sorts of things are available, and they can all come together in ways that the basic science hasn't foreseen, and we're constructing that with this engineering phase. And guess what? I'm not the only one to say that there's hype there. Even Sam Altman, even Yann LeCun, even Bill Gates, and certainly Gary Marcus. Gary has always been very vocal about that hype. So what we're here to think about is both the possible and the probable, but keep in mind the probable that we need to do in the next decade as schools versus the possible that we need to prepare for in 20 or 30 years from now. And think of that simultaneously. Oh, by the way, in addition to what we're doing tomorrow. So 3 horizons, right? Simultaneously, not one after the other, because then it's too late. We have to prepare now for what's needed in the next 5 years and beyond. And for these systems to become much more capable, they're going to need to use more than one type of algorithm. Okay, so there are multiple families of algorithms, and getting them to play together is really hard. And so forecasting the next breakthrough, which is required, is not easy. And so whomever says all you need to do is just add more compute cycles, in my opinion, and the opinion of many, wrong. You cannot fly a plane to the moon if you load it with more fuel. A plane is a plane, a rocket is a rocket. We need a rocket to go higher. Nevertheless, and this is why I keep bringing you back to reality and keep in mind the future, this present phase is incredibly powerful. We can do a lot of things. And that's because we have algorithmic progress. We have tons of developers around the world. We have verticalized data sets for education and healthcare and so on. We have faster hardware, and on and on. So this phase, again, the quote-unquote engineering phase, can produce a lot. And that's what we're going to be seeing. In the meantime, our ability to adapt to technology change is rather poor historically, and particularly in the public sector. And yet, you know very well that you have to run to where the ball will be, or for those of you who skate, to where the puck will be. And that's the reality. And that's the hard thing for humans to do because we want to see the data before we act. But once we see the data, it's very frequently late, if not too late. And so this requires both feedback and feed forward. We need to think ahead, prepare for that phase rather than wait for that phase to be upon us and try to react. It takes a lot more energy to react once we start seeing data. For example, global warming. Right? We wait from the 70s onward, and now it requires 100, 1,000 times more energy to change that system. So better be prepared ahead of time. So what's the impact on employability? You've seen plenty of reports, this is from the IMF, saying, well, jobs will be impacted. Depending on the jobs, they will be impacted more or less. But it's really, really hard to understand because people confuse the AI's ability to pass a test, like say the medical exams or the legal exams, with the ability to perform a task, and that with the ability to do a job. Let me illustrate. Just because you can do the cleaning with a cleaning agent doesn't mean you can do the washing. Just because you can do the washing doesn't mean you're doing the laundry. Different skill sets, right? And so it's a bit like confusing. If you want another analogy, it's confusing the gasoline for the piston with the engine, with driving the car. Completely different skill sets. And that's where it's really hard for economists to act because we don't have extremely good data on what constitutes a job. We have only self-reported data. And we know that self-reporting is very fraught with errors. And so even for you as teachers or heads of schools or whatever, if I was to ask you to describe your job, you'd have a certain view of it. But it's not anywhere near as detailed as if we had a cognitive task analysis done, you being followed by experts figuring out what it is that you're doing. We don't have with economists. And so when they go and say, oh, well, just because we can do the washing, therefore we can do the job, the therefore is completely wrong. Doing the job is about adaptation and coordination and so on, and those are super hard for AIs to do. Just another list of things that lawyers do. So before you run and say, I'm going to automate my lawyer, ask yourself the question, why would you need a lawyer to begin with? Just kidding. Okay. But the cool thing is that AI has also shown it can help the left side of a distribution. Here with consultants, the less capable consultants have been more helped by AI than the more capable ones. Well, because it's a diminishing return situation. If you're already really, really good at your job, there's only so much increment that you're going to get out of a boost. However, if you're struggling a bit, you're going to get that help. So for all of us who are concerned about equity issues, let's keep that in mind. It can actually help. And we have a very poor track record at figuring out the new jobs that will emerge. So this is the World Economic Forum admitting that they didn't fully forecast the emergence of these jobs. I mean, seriously, who thought that influencer would be a job? I mean, really, I still have a hard time with that one. But there you go. It's a job. It was created by emerging technology. And so plenty of jobs get created, and economists or the rest of us have a hard time figuring out what they are going to be. Also, we underappreciate the fact that people adapt. You have employers and employees rushing to adapt to this new reality. It's not that people are just sitting ducks waiting to be run over. And so human adaptability is, of course, a great thing. Keep in mind, adaptability in your context. It's not just for employers and employees, it's us as educators. What do we need to do to adapt? And so the way you can think about it is, sure, some tasks will be taken away by AI, but hopefully there will be emergence of other things that humans can now do with machines a lot faster, a lot better. What they are, we don't really know. But we know they will be there. And yes, we also know that some jobs will be negatively impacted. And so what does that say? We have to be adaptable. And the thing is, we tend to overestimate change in the short term and underestimate it in the long term. Here's an example. Back in 1899, Jean-Marc Coté, a French cartoonist, was asked to do a bunch of cartoons about year 2000. And this is how he saw the robot. Well, keep in mind, at the time, mechanical engineering was the hot technology. And there were no cheap, small electric engines like we have now for robots. So you had to drag the thing with a mechanical contraption. Made sense. Now we have Roomba. You could not have imagined Roomba because there were no electronics at the time, never mind the motors. So that's the situation we're in, right? So we don't really know, and anyone who will say that they do, come on. Maybe they're hallucinating. So the thing is, okay, here's the conclusion. All the jobs automated, that's really, really, really poorly defined. But we also know that some of these AGI, generalized capabilities, are going to happen within the lifetime of our kids, perhaps even in our own lifetimes. Exact capabilities to be determined. So what should we do, right? I mean, are we going to just say, okay, well, we surrender. I'm going to leave my kid at home, and by age 20, they will magically decide what they want to do with all of these genies at their disposal? Of course not. They still need scaffolding. They still need an education. And very likely, they're still going to need a job. And never mind job. They're going to need to live in a world that's much, much more complex. So how do we prepare them? So, if you start looking at Bloom's taxonomy, you might say, okay, time to go home, we're doomed, it's over, right? You can do all these things. Okay. And you can look at the affective domain thinking, well, perhaps we can find refuge there. And no, I'm sorry. AI can detect empathy signs on one's face better than I can, and most people can. Seriously. It can detect our heartbeat at a distance, just looking at the flushiness of our faces. And on and on and on. It can repeat the same story to our little girl for the 5,000th time, right, for those of us who have kids. When was it that the 4,999th time you had the same energy and enthusiasm to read the same book with your kid? The AI will just be as chipper as ever. Yeah! One more time, thank you. Okay, so affective domain, let's be serious. You know, we don't necessarily have a blanket advantage here. Psychomotor domain, okay, well, you know, we've lived with this forever. You know, we don't fear cranes and trucks, except being squashed, of course, but we don't fear them as, oh my God, they're displacing us. Well, yeah, sure, they have displaced people, but the people have done other things. So the psychomotor domain is perhaps a good analogy to think about, well, you know, we adapted and we moved on. And so we have to adapt and move on, but the devil is in the details. The devil is in the details because when we say AI can or AI cannot, it's a big blanket statement. Can AI be creative? Okay, what do we mean by creative? Incrementally? Radically? Do we mean developing personal tastes, aesthetics, and style? Do we mean generating and seeking new ideas, etc.? What are the components of creativity? And that's a sort of deep analysis we've done to understand what these components were for all these competencies. And then decide whether AI could or could not achieve them now or later, and whether they can have an additional help to us. Super important. Just to give you the net result here, it means that as we teach for creativity, we have to pay a lot more attention to imagination, because that's the sort of radical innovation that AIs are not able to do today, because there's statistical models that give you an average answer. It's not going to give you the best possible answers. And so we have a role there. And when we think about creativity, not only should we think about all the elements of creativity, but even when it comes to innovation itself, we have to figure out how to push on the imagination front. So an example of how complicated it is, it's not, oh, it's creative, or oh, we're doomed, or whatever. So this is not the first time it has happened. We've had this race between technology and education for a while, right? We've had, with the Industrial Revolution, the first zooming ahead of technology, and we had to catch up by inventing mass schooling. And now we have the same zooming ahead of technology, for which we have to mass sophisticate the what and the how we teach. And of course, we are dealing with a world that's all the more volatile, uncertain, complex, and ambiguous. And so what do you do in a world like that? Our view is we don't know what's going to happen. Really more unpredictable than ever, more changing than ever. So wouldn't a wise strategy be to develop as much versatility as possible? And hey, I just realized, Geneva, Swiss Army knife, makes sense. How did I not think of it? It was really not meant. Hey, good coincidence. Swiss Army knife analogy, right? You have all the tools, much broader set of tools than just one knife or one bottle opener. Although if you have the right wine, just one bottle opener may be all you need. But you can have this palette of tools, and then depending on the situation, you sharpen that tool. But we give you, as an education, the broad set. We give you as broad of a set as possible. And that means breadth of knowledge, not just depth of knowledge. And balancing the two has become more complicated because there's so much more knowledge to have, but you cannot know it all. So what are the bits worth knowing? Well, you've seen this model before, and of course the IB has a similar one related to knowledge, skills, character, and meta-learning. And we've done research with the IB to show how that was deployed across the various programs, and what was well covered, what was needing to be more covered. And so we know that we're in sync there. It's just a question of being more systematic, comprehensive, and demonstrable. Let's talk about knowledge for a moment. Excuse me. It is tempting to think that, oh, well, we don't need any declarative knowledge. Just as naive as saying, well, Google knows everything, quote unquote. It does not. It indexes everything. It doesn't know anything. Second, you're not going to have a human being functional if every other word they have to pull out their dictionary and say, what did you mean by that? Because your kid has a 500-word vocabulary. Okay, same for math, same for everything. So we still need declarative knowledge. No question, you're not going to build all of these competencies on the basis of nothing. But we have to be more choosy about what there is. I'll show you examples in a second. We need, of course, to keep on building the procedural knowledge, the how do you do something with what you know, the conceptual knowledge, which, of course, you embrace as part of the IB, and finally, the epistemic knowledge aspect, what is my discipline about? Theory of knowledge, etc. So you guys are already very well prepared along those lines. It's a question of making it more explicit, more systematic, more comprehensive, and more demonstrable. Example, why teach so much trigonometry besides simply sine, cosine, and tangent, and so little data science? Why do we push data science as well for those who don't hack calculus? Why not discrete and computational math? Why not debate and comedy and improv? Why not manufacturing? Why not world literature? Why not world history? Of course you do some of these things. Of course you do. The question is, are we doing enough of these things for a modern world? So there's a rebalancing that needs to take place here. And sure, we have done work with Australia, for instance, to revamp the mathematics standards to show how much more time we should be spending on stats and probabilities and on discrete and computational math, not just on the canonical branches of mathematics. And same thing about world history. We have 660 records in our database of important events and artifacts. Same thing for world literature. We have 275 works of literature from all cultures, not just Anglo-Saxon culture, covering just about any theme, any topic you care to cover. Again, you guys do a lot of these things already. We're talking about making them more systematic and more comprehensive. And then, now that we have cleaned up the traditional disciplines, what about modern disciplines? Again, you guys do some of these things, but they're typically optional. And what we're contending here is that in a broad education, these are mandatory, not optional. We talk about STEM, but we teach MS, small t, occasionally, and 0E, and we still call it STEM. Why not engineering? What's wrong with teaching civil, electrical, mechanical, and manufacturing engineering in middle school, in the MYP program? Why not? Well, because we think of engineering as being heavily laden with math, but there's a way to make it all concept-driven, not math-driven, even for a kindergartner. Again, computer science, of course, we do, but why microbiology, not biotech? Why physics and not also clean tech? Why chemistry and not also nanotech? This is how you modernize some of these traditional disciplines. Then, again, we talk about needing to understand each other better and ourselves better. And psychology, sociology, anthropology are typically options when you're lucky to have them as options. Again, why aren't they mandatory? Why can't we rebalance the traditional disciplines with these modern disciplines that matter for the future? Same for entrepreneurship. It is the job of the future. That is the job of the future. So this is how you can think of modernizing knowledge. But then, of course, we talked about skills and character meta-learning. When I wrote 21st Century Skills back in 2008, after that, I felt quite happy to see that 110 plus countries had put that in their curricula, standards, etc. But here comes the sad part. When we did a piece of research with Brookings just a few years ago, no jurisdiction offers significant pedagogy and demonstrability via assessments. And so here these things are talked about, they're put as portrait of a graduate, learner profile, you name it, and it doesn't get done because we don't have this deep embedding of these competencies in the content, in the curriculum. There's something that most jurisdictions throw at teachers as a bunch of PDFs to add when they can. And AI, as I was saying, is also going to modify which aspects of competencies is going to matter more. Look at courage and resilience. We talked about resilience, about reading to your 5-year-old the same book for the 5,000th time. It's tireless. But think about courage. When AlphaGo won against Lee Sedol at Go, it used a strategy that no human would think about. Whether or not you play Go, here's the shortcut. You win Go by having a certain amount of squares, real estate. And so, as a human strategy, you try to maximize this real estate. It's obvious. You don't want to be too close to the edge. Well, AI can compute 50 or 60 moves ahead, and therefore it can compute that it can win by just half a square. That's enough to win. And so it is going to take the kind of risk that a human would never take. It's fearless. If you train a fighter pilot, an AI fighter pilot, to fight against a real pilot, what's the AI going to do? It's not going to do Top Gun and try to maneuver and do loops and so on just to please the audience. No. It's going to literally plunge against the other fighter and try to shoot first. It's fearless. So we have a lot of actions in our behavior that relate to fear that we're not even conscious of. And that's what I like about AI. It's putting the spotlight on so many things that we have done in an automated way through our evolution, whether it's how we assess or how we define courage, etc. So it's a nice spotlight, like the one that's making me blind here. Let's talk about personalization. So in a world of AI, it's going to be harder and harder to motivate the students, right? This is called in psychology cognitive miser, right? We're all cognitive misers. Evolution has wired us to be lazy, listen to me, lazy by good evolutionary design. That's what we are. Because if we weren't, we would have not survived evolution. Because we have spent too much energy on so-called system 2, trying to constantly think about every new situation rather than just the situation fast. Rustle in the grass, better move, might be a snake, rather than, let me explore whether it's the wind or the snake. So we have these two systems, one to react fast, and we use it profusely, and in most cases, it's a good thing. Unfortunately, it's how we judge people by what they look like, etc. It's also the bad part where it overrides our logic. And so the trick here is to understand how lazy we are because of good evolutionary design. It drives our creativity. Hey, I invent the wheelbarrow. That's a lot better than carrying the whole pyramid on my back. Right? So we do things like this. And so our students, very naturally, are going to try to be as lazy as they can. If you don't, yeah, it's normal. I would be. You would be. Let's be serious. If you don't justify to me why I need to learn when I have a much more powerful tool in my hand, sure, I'm not going to be particularly motivated. And that's why, in addition to knowledge, skills, character, and meta-learning, we have to pay a lot more attention now to identity, agency, and purpose. Imagine the beautiful future sci-fi scenario where we have the genie from the lamp we can invoke at any time, and we can give it a wish. Do something. What kind of wish should we give it? Sense of purpose. So, keeping in mind that AI does have an identity. It has an identity via the data sets it has ingested, via the algorithms it's running, and via the user interface that it has. It can react to you as Socrates or as me. You can train it to do all sorts of things like this. So it does have an identity that we confer to it via its training and its user interfaces. But it has very limited agency, and hopefully we're not going to give it too much more, although that's happening with autonomous weapons. Yeah. But AI is generally passive. Humans are the ones who have a sense of purpose, and humans are the ones to decide, what do I want to do with all of this? And that's why it pushes us to think even more carefully about the wisdom we have to exercise and wisdom we have to train to get to this point. So, just looking at purpose without going into too many details about the rest, a reason for being is multifold. Sure, it's wonderful to tell your kid, do what you love. But it would be nice for those of us who are parents to also have the kid move out of the basement at some point. And that means do what you can be paid for as well, not one or the other. And do what you're good at. And really do what the world needs. That's a broader sense of purpose that every single one of us, every single one of their kids should have. And act locally, act globally within their means, in their future. And so, to help with that, we constructed this database of 340 projects aligned to the UN SDGs, the World Economic Forum, Grand Engineering Challenges, and so on. Because now, as you're deploying a project about just about anything you want, you can click, select from the database projects that are already aligned to disciplines, to competencies, and give the student a purpose. Okay, let me go through an example. Let's say that we all have to build a robot. It's a modern world, no one can escape that. Robots. So, Faris, I'm going to say, well, I'm a teacher. Faris, what kind of robot would you want to build? And he's going to say, well, I like marine robots, stuff that goes in the ocean. Fine. Oli-Pekka, what kind of robot do you want? He's going to say a flying robot. Say, okay, great. I can see the technical challenge in your mind. Now tell me what's the purpose. Faris will say, marine robot. Hey, I can count plastic particles, or I can survey groups of dolphins, or whatever. That's a purpose. And same thing, Oli-Pekka can say, hey, I want something to fly over fields and detect mines, or help crops. So you see how you have the agency of what type of robot, and you have the purpose of what the robot is for. All these things work together. So it's not like you're breaking sweat by adding these things. They all come together seamlessly if we design the curricula properly. And of course, as a reminder, life is a mess, and it's not neatly organized by disciplines. And the more we can train students for the real world, the better it is. Real world in terms of life, not just work. Okay. Lastly, let's talk about advances in personalized systems. We are very limited in our imagination, as I was saying earlier, and this is how Jean-Marc Coté saw in 1899 that we'd be learning. There was electricity at the time, and there were meat grinders. And so if you put enough books, you come up with the open internet. Way! So that's a metaphor. And of course, the metaphor about the hearing systems is what we call intelligent tutoring. And before we get there, I would love to see us spend a lot more time on helping the teachers ramp up their game, become better at their art. There's no scenario in my mind where the teacher is replaced, and there shouldn't be. We all know that learning is social, etc. That's not going to be easy to replicate with a bot. Even if the bot is more patient than us, by the way. That means we're designing an exobrain, like an exoskeleton, right? So that the teacher can do more without, again, taxing themselves too much. And that means things such as a chatbot specifically trained on education research, 138,000 peer-reviewed papers, plus our own databases that are going to give you the right answer rather than what Joe thinks on Reddit, because that's what LLM XYZ has decided to give you the answer for. So fewer hallucinations, better data sets, better results. And on the other side of all this, we also need to design assessment systems that close the loop, right? So on one side, we want to help the teacher with lesson plan design, with the chatbots, et cetera. And on the other side, we have to manage and close the loop. Adaptive learning has shown promises for a long time. It allows you to self-pace as a student, and we may see better improvements thanks to AI in closing the 2 sigma gap that Bloom talked about. And it may allow for learning time reduction. This is what we see in the corporate world. Question is, how are we going to adapt this to the education world? I think it's going to be a mixture of things. I think we're going to see this number of gray zones going from 100% teacher control to 100% ITS and student control, and every scenario in between. And it may depend on the kid's ability to be self-directed. It may depend on the discipline that is more or less threaded, like math may be more easy than literature, et cetera, et cetera. There's a lot to figure out, even if the technology was already good enough, which it isn't. But in the next 5 to 10 years, it will be a question we have to ask ourselves. What is the right blend? And one of the things we have started doing, and you're the first audience that's seeing this, journalists anywhere? We have created a student database of 1 million learnoids, as we call them. It's basically synthetic students from which we can do tests on how we can find patterns in data. We don't need to have real data to run simulations, so we created synthetic students, and we can do a lot of things. That's what they do in healthcare, by the way. It's not just education. When you have only 50 patients, and you need 50,000, what do you do? Well, you take the 50 patients and you randomize them intelligently, and now you get 50,000. You can continue on to 1 billion if you want. We stopped at 1 million. So this is going to help us, once we have real data, to be prepared on how to analyze it, and also to derive theories of mind based on the data we'll see. Because typically in the past, we had to come up with a theory and see how it plays out. Here, we're going to see a lot of data and see what we can infer out of the data. So, to conclude, I'm going to quote Yuval Harari. You know, technology is amoral. It doesn't have a moral. It gets used by humans. It's the humans that do good things or bad things with it. And that's why, you know, it's not AI that we're concerned about. It's the misuse of AI. And misuse could be benign, like not understanding how to use it properly in a classroom, or it could be terrifying, like autonomous weapons. It's up to us to build the wisdom in our students and our populations at large to figure out how to be wise about technology and how to lead in a world that is becoming infinitely more complicated. So with that, I'm going to thank you, remind you of the following. First of all, thank you, Oli-Pekka, for writing the prologue to this book. Him and I are going to be in room Archives M4, as I said earlier, at 5:15. We're distributing a number of books. We only have 40 seats left available. So if you're interested, join us for more Q&A. We're going to do Q&A now. And I'm going to leave this up in case you want to take a picture of the QR code. All right, with that, I thank you very much.